Every single night you get behind the wheel after dark, you're making split-second life or death decisions with less than half the visual information your car was engineered to give you. You're driving blind right now, and you do not even know it. According to testing published by the Society of Automotive Engineers, the average clouded headlight lens reduces light output by up to 79%. It does not matter if your bulbs are brand new. That light is trapped. A 2015 study in the journal Accident Analysis and Prevention identified headlight degradation as a direct contributing factor in 23% of nighttime pedestrian fatalities. This is not a cosmetic issue. It is a mechanical failure, and the auto industry knows it. They have built a $6.2 billion headlight replacement market around selling you entirely new $900 assemblies or $25 polishing kits that deliberately fail after 2 months. But Japanese fleet operators have been using a $5 aerosol spray, a specific two-component industrial chemistry, to permanently mimic the factory UV hardcoat and make headlights crystal clear for up to 5 years. Today, I'm going to expose the 1987 engineering flaw that caused this, the exact chemistry dealerships hide, and the foolproof driveway protocol to fix it forever. Now here is the part almost nobody tells drivers. The cloudy, yellowed, oxidized look on your headlights is not some random sign of age that nobody could prevent. It is the predictable result of a known materials failure built into millions of modern vehicles the moment manufacturers switched to polycarbonate plastic lenses and relied on a thin factory-applied UV protective coating to keep them clear. That coating works beautifully when it is new, but once sunlight, road salt, heat cycles, detergents, and airborne pollutants start breaking it down, the lens surface is left exposed. The plastic begins to oxidize, microcrack, and scatter the beam instead of projecting it forward where you actually need it. So what looks like a little haze on the outside is really your headlight system losing its ability to do the one job it was engineered to do: let you see danger before it is too late. The industry's answer is not to solve that failure at the chemical level. Their answer is to monetize it. That is why so many drivers get pushed toward full headlight replacements that can cost hundreds, sometimes close to $1,000 per side, even though the underlying problem is usually sitting on the outer lens surface. And that is where the polishing kit illusion comes in. The auto parts industry has built an entire repeat purchase business model around those little restoration kits hanging on store shelves, a market worth roughly $400 million. The promise is always the same. Spend $20 to $25, scrub the lens, sand away the oxidation, buff it out, and your headlights will look almost new again. And for a few weeks, they often do. That short-term success is exactly what keeps the cycle alive, because the sanding and polishing step removes the dead oxidized layer, but it also strips away whatever remains of the original factory hard coat. What most of those kits do not give you is the one thing that actually determines whether the fix lasts: a durable replacement UV seal that can bond properly to the exposed plastic and protect it from reoxidizing. In other words, they restore the appearance temporarily, but they do not restore the engineering. The result is predictable. 8 weeks later, maybe a little longer if the car is garaged, the haze begins creeping back. Then it gets worse, and the customer assumes the headlights were just too far gone, so they buy another kit, or they give up and pay for replacement assemblies. That is the scam hiding in plain sight. The critical chemical layer is missing, not by accident, but because a permanent fix kills repeat sales. And once you understand that, the entire headlight restoration business starts to look less like maintenance and more like a carefully managed failure loop designed to keep you spending money on a problem that should have been solved the first time. The story starts in Tsukuba, Japan, in 1987. And almost nobody realizes how much of modern night driving was shaped by what happened there. That was the year Stanley Electric introduced the world's first multi-reflector headlamp, a breakthrough that completely changed automotive lighting design. Before that shift, automakers relied heavily on glass lenses, thick, heavy, expensive to manufacture, and far more restrictive in terms of shape and beam control. Stanley's innovation opened the door to a new era. By using precisely engineered reflector geometry behind the lens, manufacturers could control and direct light with far greater efficiency, while also freeing themselves from the physical limitations of glass. And that is what made polycarbonate plastic so attractive. It was lightweight, impact-resistant, cheaper to mass-produce, and easy to mold into the sleek, aerodynamic shapes that defined the next generation of vehicles. When the Honda Accord brought this technology to the American market in 1990, it was not treated like a warning sign. It was treated like progress. Then the rest of the industry followed. Fast. Within a few short years, the global auto market had embraced polycarbonate headlamp lenses almost universally. What looked like an elegant Japanese engineering triumph became the new standard on millions of vehicles. But hidden inside that breakthrough was a flaw so fundamental, so chemically inevitable, that it guaranteed one day nearly every one of those lenses would begin to fail in exactly the same way. To understand the flaw, you have to understand the material. Polycarbonate is not weak plastic. It is one of the toughest transparent engineering materials ever mass-produced. It is used in applications where strength, impact resistance, and optical clarity all matter at the same time. Bullet-resistant glazing, aircraft canopies, protective shields, industrial safety equipment. On paper, it seems perfect for headlights. It can take abuse that glass cannot. It will not shatter the same way. It is lighter, safer, and more flexible from a design standpoint. But polycarbonate has one catastrophic vulnerability, and it sits above your car every single day in plain sight. It is not naturally UV resistant. The moment those lenses began spending years under open sunlight, the clock started ticking on a molecular breakdown process that most drivers have never heard of, but every materials engineer understands. Under ultraviolet exposure, especially UVA radiation in the 315 to 400 nanometer range, the carbonyl structures within the polymer begin to destabilize. That process is called photo-oxidation, and it is not surface dirt, road grime, or some harmless yellow film you can wipe away with a towel. It is molecular degradation. The polymer chains at the outer surface begin to break down, oxygen interacts with the damaged material, and the lens starts developing microscopic cracks and roughness from the outside inward. At first, the change looks cosmetic. Then it turns optical. Instead of allowing light to pass through cleanly, the damaged surface begins scattering and diffusing the beam. The light that should be projected down the road gets weakened, distorted, and thrown in useless directions, including upward and outward into the eyes of oncoming drivers. So the real danger is not just that you see less, it is that the entire optical behavior of the headlamp becomes corrupted by a failure taking place at the molecular level. And here is the part that makes this story even more revealing. The original engineers knew this would happen from the very beginning. They were not careless. They understood exactly what polycarbonate could do, and exactly what it could not survive on its own. That is why the factory process never relied on raw plastic alone. OEM manufacturers applied a UV-resistant hard coat directly onto the lens surface, then cured it under controlled conditions so it would form a protective barrier against sunlight, abrasion, and environmental attack. That hard coat was the real defense system. It was engineered to preserve clarity, maintain beam performance, and hold off photo-oxidation for roughly 7 to 10 years under normal conditions. In other words, the hazing problem was never a mystery. The industry knew the lens would fail once that protective layer eroded, and yet, instead of pushing aggressively toward better long-term consumer recoating systems, better aftermarket restoration chemistry, or affordable permanent renewals, the market moved in a completely different direction. Why? Because degraded headlights became a recurring revenue machine. Once the original hard coat wears out, the customer has very few durable options. They can buy a temporary polishing kit that strips the surface but rarely restores true long-term UV protection, or they can be steered toward full replacement assemblies at massive markup. That is where the economics change the engineering story. A permanent consumer fix is bad for repeat sales. A lens that fails gradually, predictably, and expensively is far more profitable. So the industry allowed the problem to remain manageable rather than truly solved. And that is why something born as a Japanese engineering breakthrough in 1987 eventually became one of the most quietly profitable failure points in the modern automotive world. The proof that makes this impossible to dismiss comes from the kind of place that does not care about gimmicks, trends, or internet hacks. It comes from fleet maintenance, where every repair decision is judged by one standard only. Does it save money without creating future failures? In Osaka Prefecture, a fleet maintenance coordinator overseeing 34 Toyota Hiace commercial vans reportedly turned this exact headlight restoration method into a standard operating procedure all the way back in 2001. Not as an experiment, not as a one-time shortcut, as policy. And that is what makes the story so powerful. Over 23 years, across 4 separate generations of vehicles, not a single one of those vans ever needed a full headlight assembly replacement because of oxidation. Think about what that means. These are not garage-kept weekend cars. These are working commercial vehicles, exposed to sunlight, weather, road grime, heat cycles, and the kind of daily abuse that destroys weak fixes fast. And yet the total cost per application cycle stayed at roughly 800 yen, less than $6, while the vans continued passing Japan's notoriously strict shaken road inspections every 2 years. That is the kind of real-world evidence that auto parts shelf kits can never match, because this is not about whether a lens looks shiny for a few weeks in a driveway photo. This is about whether a coating can survive years of real service and preserve the optical performance required for legal roadworthiness. In other words, the Osaka fleet story destroys the idea that permanent restoration is some fantasy. It proves that when the chemistry is right, replacement is optional. And that brings us to the real science, because the miracle is not in the polishing. The miracle is in what comes after. This is the part the $25 polishing kits leave out on purpose, the protective barrier. When you sand and polish a cloudy lens, you're removing the oxidized outer damage and exposing fresh material underneath. That is why the lens suddenly looks clear. But what you have also done, whether you realize it or not, is strip away the remains of the original factory UV hard coat and leave raw polycarbonate exposed directly to sunlight and oxygen. And raw polycarbonate is defenseless. Once unsealed, it begins degrading again almost immediately. Not in theory, in hours. That is why so many DIY restorations look amazing on day one and then slowly collapse back into haze, yellowing, and surface failure within weeks or months. The polishing was never the complete repair. It was only the prep work. The true repair is restoring the missing shield the factory originally applied. And the product that does that is not a wax, not a wipe, not a gimmicky sealant packet, and not ordinary clear spray paint. It is 2K UV clear coat. 2K means two component, and that distinction changes everything. Inside that can are chemicals designed to react and cure into a hardened, chemically cross-linked protective film. This is not just paint drying on top of plastic. It is a structural coating system forming a dense, durable barrier that resists UV attack, environmental wear, and surface breakdown in the same basic class of chemistry used in professional collision repair. That is why this spray works when the cheap kits do not. A proper 2K clear coat uses an isocyanate cross-linked acrylic resin system with built-in UV absorbers, which means the coating is engineered not only to harden, but to actively defend the lens against the exact radiation that caused the original failure. This is professional-grade coating chemistry, scaled into an aerosol format. In a body shop, the same category of material can cost hundreds of dollars per quart, because it is trusted to restore and protect exposed automotive surfaces under real weather conditions. But in aerosol form, products like SprayMax 2K make that chemistry available in a can that often costs only $5 to $8 per application range, depending on where it is sourced and how much of the can is used. And that is the hidden secret. The permanent fix was never magic. It was never some underground mystery fluid. It was simply industrial coating science applied correctly to a problem the consumer market prefers to treat badly. Once you understand that, the entire headlight restoration world snaps into focus. The sanding is not the solution. The polishing is not the solution. The solution is recreating, as closely as possible, the factory-grade UV hard barrier that the lens lost years ago. That is why the Osaka vans kept passing inspection. That is why the haze did not come back on schedule. And that is why a $5 spray can outperform an endless stack of polishing kits that were never designed to finish the job in the first place. The final piece of this entire restoration is the part most people rush, and that is exactly why most people fail. Preparation is not half the job here. Preparation is almost all of it. If you get the prep wrong, the coating fails. If you rush the sanding, the finish fails. If you leave oils on the lens, the coating fails. So, before you touch the car, get every material in front of you and do not improvise. For under $12 in total application cost, you need 4 sheets of wet eye-dry sandpaper in 400, 800, 1500, and 2000 grit, a spray bottle filled with clean water, painter's tape, 90% isopropyl alcohol, a clean lint-free cloth, and 1 can of SprayMax 2K 2-in-1 headlight clear coat. That is the entire system. No mystery products, no overpriced restoration kit, no dealership package, just abrasives, water, proper cleaning, and the one chemical barrier that actually matters. Start by taping off every painted panel, trim edge, and sensitive surface within at least 6 inches of the headlight lens. Do not get lazy here. Overspray travels farther than you think, and 2K clear is not something you want landing on your paint, grille, or chrome. Once the area is protected, begin the wet sanding phase, and understand this clearly. Sanding is not damaging the lens. Sanding is removing the failed coating and oxidized layer that has already destroyed the lens performance. Keep the lens wet the entire time. Start with 400 grit and sand each lens for roughly 3 to 4 minutes. This is the most aggressive stage, and it is supposed to look ugly. The lens will turn heavily scratched, cloudy, and terrible looking. That is normal. That means you are cutting through the dead factory hard coat and leveling the oxidation. Once the surface looks uniformly scratched with no remaining glossy patches, move to 800 grit for 2 to 3 minutes per lens, again keeping everything wet. Then switch to 1500 grit for about 2 minutes, smoothing the deeper sanding marks into a finer, more even haze. Finish with 2000 grit for another 2 minutes until the lens looks smooth, evenly frosted, and consistent across the entire surface. If you still see uneven yellow patches, shiny islands, or random deeper defects, do not move on yet. The coating only looks as good as the surface underneath it. Once sanding is complete, the chemistry phase begins, and this is where people accidentally sabotage everything. Rinse the lens thoroughly with clean water, dry it completely, and then wipe the entire surface with 90% isopropyl alcohol using a lint-free cloth. Do not just dab it, wipe it thoroughly and deliberately to remove sanding residue, skin oils, moisture, and contaminants. Then stop touching it. Let it sit and dry for a full 5 minutes, not 1 minute. Not until it looks dry, 5 full minutes. No fingerprints, no dust, no greasy hands. Because if oils remain on the polycarbonate, the clear coat can fisheye, peel, or fail to bond properly. Now activate the SprayMax 2K. This is not ordinary aerosol paint. It is a true two-part chemical system, which means the resin and hardener remain separate until you trigger them. Remove the red cap button from the top of the can, place it onto the pin at the bottom, and press firmly to release the internal hardener. Then shake the can aggressively for a full 2 minutes. Not 20 seconds, 2 full minutes. You're mixing a chemical coating system that now has a limited working life. Once activated, you have roughly 8 hours before the material begins hardening inside the can, so do not activate it until the lens is fully prepped, cleaned, masked, and ready to spray. When spraying, hold the can 8 to 10 inches away from the lens and lay down the first coat in smooth, controlled passes. Do not stop in the middle of the lens. Do not wave your wrist. Move evenly across the surface and slightly overlap each pass so the coating lands uniformly. After the first coat, wait exactly 10 minutes for flash time. This pause matters because it allows solvents to escape and gives the second coat the proper surface to bond to without sagging. Now, apply the final coat slightly heavier than the first, again using smooth, overlapping passes from the same 8 to 10 inch distance. The second coat is where the lens transforms from dull and frosted to deep, clear, and factory looking. But this is also where greed ruins the result. Do not apply a third coat. More is not better here. A third coat often causes orange peel texture, uneven film build, and a finish that looks thick instead of clean. 2 coats is the sweet spot. Once the second coat is down, walk away. Do not touch it. Do not test it with your finger. Do not pull the tape too early, and do not drive the car immediately. Let the coating cure for at least 8 hours before driving, and give it 24 hours if you want maximum chemical hardness and long-term durability. And when you step back and look at the result, remember what just happened. A dealership would gladly quote you anywhere from $380 to $900 for replacement headlight assemblies, all because the original UV hard coat failed. But instead of falling for the replacement trap, you just recreated the essential protection layer yourself. You permanently replicated the heart of that 1987 Japanese factory hard coat system for about $12 and a little patience in your own driveway. That is the difference between understanding the problem and being exploited by it. And subscribe right now because in the next video we are exposing the $1 Japanese backup camera trick that restructures the surface tension of your lens glass, making it self-cleaning forever. The dealership charges $80 for a service that this $1 mineral completely eliminates. You do not want to miss it.